Hello everyone, welcome back to the Geographical Investigation series Data Gathering Methods for Coastal GI. So in this video we'll be looking at analyzing wave frequency, which is one of the methods that you can use for your coastal GI. Alright, so just as the other videos have covered, we'll be going through these three questions. When do I use this method? How can I carry it out? And lastly, what do I need to consider when carrying out this method? So let's tackle the first question. For analyzing wave frequency, when do I use this method? Basically, we will use this method when we are trying to determine if the waves at the coastal area is constructive, whether it builds up a coast, or destructive, meaning it erodes a coast. Alright, so some of you may be wondering, why should I even know about this information in the first place? Okay, so whether waves are constructive or destructive has impacts on beach profile. So as you guys have known, coasts are very dynamic landscapes, and what actually shapes them? Waves are actually a very important force in shaping coastal areas. So if erosion happens more rapidly as compared to deposition, you can expect steep gradients. So as you can see in this picture here, my question to you is, what kind of waves produce such landscapes? So is it constructive or destructive waves? Let me know in the comment section below. Alright, so simple as that. So now the second question that we will be tackling is, how can I carry it out? So you will firstly need to know what you need to have before you can carry out this method. You need three things, very simple. You need a ranging pole, one ranging pole. You need a recording sheet to collect your data. And thirdly, you need a stopwatch. Alright, let me pull out this diagram for you. So imagine that you are at a beach. Alright, so I want to do this analyzing wave frequency. Basically, I want to find a location in the near shore zone that is not too deep. Okay, so you have to get into the water, but make sure you do not go in too deep. So over here I have denoted this ideal area through the letter X. So this is where you're going to actually carry out your next step. Next, identify a point on your ranging pole which you will use to count the number of waves and place it at area X. So as you can see here, it is denoted by this yellow marking over here. So when the wave hits that point, for example, it will be recorded as one wave. Okay, so as the wave is crashing on the shore, you will hit this yellow marking, and then you will count how many waves hit that particular point. So I put it in at area X there. So what will happen is then I would record the number of waves that hit that point for a duration of 5 minutes. So you take a stopwatch. When you're ready, make sure you time for 5 minutes. What you will actually see is something like this. So observe the wave as it hits the yellow marking on the ranging pole. So you see the wave moving, hit, so that will register as 1, for example. So basically just hold it upright, time for 5 minutes, and then count how many times does that actually happen. Okay, so you have more waves. Then after you time 5 minutes, okay, 5 minutes done, then you will divide the total number of waves recorded in 5 minutes by 5, because you measure 5 minutes, right? Now you want to find out what is the average number of waves per minute. So in order to find that, you divide the number of waves by 5, which is 5 minutes. So for example, I recorded 10 waves over 5 minutes. Okay, so remember, you put your observed number of waves divided by your time, which is 5, so you get 2 waves per minute. So my question to you is, based on the number of waves per minute, so we have 2, right? Was it constructive or destructive? So now that you have this information, you guys have knowledge about how to identify your constructive or destructive waves. You have to deduce whether it is constructive or destructive. So some of the things that you may want to also consider is, what are the implications of the waves being constructive or destructive? What do you think we will see? How will this impact the coast? These are very serious questions that you need to consider as geographers. All right. Okay, so I hope you are following well thus far. Remember, if you are feeling lost or you did not catch anything, just slow down the video or even go back or rewatch a particular part that you're not sure about. Lastly, for this part over here, what do I need to consider when carrying out this method? So there is only one thing you need to consider or remember when you're carrying out this method. You need to always hold the ranging rod upright, as tilting it can lower the marking point and result in inaccurate recording. So remember that there is a yellow marking or a marking that you need to make on your ranging rod. So when you tilt it, that marking goes lower. So for example, simply water flowing can actually be recorded as one wave, and this will lead to inaccurate data. So be very, very careful. Okay? Alright, simple as that. 3 questions solved. Now you know how to do wave frequency analysis for wave characteristics, for identifying wave characteristics. Next, we'll be looking at methods to gather data about sediment transport, which is related to longshore drift. And just to bring to your attention the overview, you guys are now masters of 3 different methods. And I'll see you in the next video. Thank you for tuning in.